So the objective of this chapter is to understand the color spaces, to use the Java color class, to be able to use different type of paints in drawing visual objects, to apply stroke types, to construct affine transformation including translation, rotation, scaling, shearing, and reflection. To understand object transformation and viewing transformation, to combine basic transformations to form more complex ones, to identify the composite rule, to use clipping paths, to apply fonts and and font metrics, and at last to understand the glyph ligature and derived font. Color space. Colors are important attributes in graphics systems. The color of light is associated with the wavelength or frequency of the light. Usually, light has a spectrum of frequencies whose exact description will be complex. In practical terms, only colors visible and distinguishable to human eye need to be identified in graphic systems. A system called color space is often used to define visible colors with numerical values. Several different color spaces exist to specify colors in a precise and quantitative way. So the general approach is to select a small number of fixed primary colors such as red, green, or blue and represent an arbitrary color as a combination of these three primary colors. So the color C equal R times probability of R plus G times probability of G plus B, which means blue, times probability of blue. So the coefficient R, G, B represent the component of color C in red, green, and blue. This provide a convenient numerical specification for any color. CIEXYZ is a color standard that uses the three primary colors X, Y, and Z instead of RGB. Any visible color can be represented as a positive combination of X, Y, and Z. However, it is usually difficult to directly implement CIEXYZ in physical devices. Most monitors use RGB, red, green, blue color spaces, and printers typically use CMYK, which is the cyan, magenta, yellow, black. The combinations of the primary colors are used to represent different colors. These systems are natural to the device, but they are usually device dependent and they cannot represent all visible colors with positive coefficients. The sRGB, which is a standard RGB, is the absolute device dependent color space. It uses the same type of RGB component as in RGB system, but it standardizes the color definitions so that they are independent of any specific device. When the geometry of a shape is constructed, it can be rendered with the fill shape or draw shape method in Graphics 2D. To set the color for rendering the object, the following method of the graphics class can be used, which is void set color of color T. A color object defines a color. The color class by default uses the sRGB color space. Proposed standard, which is a proposed standard color space. A color contains red, green, blue, and alpha components. The alpha component defines the transparency of the color. The color class defines the colors like which are the constant color values like black, blue, cyan, dark gray, gray, green, orange, pink, etc. As I said before, the color class defines constant color values like black, blue, dark gray, gray, green, white, yellow, etc. Other colors can be easily constructed using one of many constructors of the color class. You may directly specify the RGB value using the following constructors. Uh, Color of int R, int G, int B. This first version specifies the three colors component using int values in the range of 0 to 255, sorry. And the second version is similar to the first, but the three values are packed into a single int value. And the third version uses float values in the range 0.0 to 1.0 to define the color components. Besides RGB, an alpha value related to the transparency of the color can be specified. The following constructors allow alpha value specification. So an additional input is added for alpha value. The following code fragment draws a three square using three different colors. First, we set the color of the graphics into red color using g.setColor of color.red. Then we try to draw a rectangle using the red color. Then we change the color to another color using the int RGB values. 0 for red, 255 for green, and 128 for blue. And also we try to draw the other rectangle using this color. And at last we use the color constructor using the RGB value which are the float values, and then we try to draw the rectangle using this color. This program displays. This is the output of the previous code in the paint, as we see in the paint component method. The 7 regions of the picture are formed from the 3 circles using constructive area geometry. Each region is filled with a combination of primary colors covering the region. For example, the region covered by the red circle is filled with the red component. The region covered by the red and the blue circle is filled with the color composed of the red and blue components, etc. So here is the output of the previous code. Here an example to transform the values from float to integer and vice versa. In the first question, construct a color object equivalent to the following using float parameters. New color of 64 to 55 128. Then we should calculate the float equivalence of this number. To calculate the float equivalent of this number, we will use the cross multiplication formula. First, we know that 255 in int correspond to 1.0 or 1 in float. So if we want to calculate the int value, we should calculate int, and if we have the int value, then we put int under 255 and the float under 1. Here we should calculate the float, then float equal int over 255. Then 64 over 255 will give us 0.25. 255 over 255 will give us 1.0, and 128 over 255 will give us 0.5. Now in the reverse, construct a color object equivalent to the following using int parameters. 0, 0.3, 0.128. If we see here, we calculate the float value. Now we should calculate the end value. Then int equal float times 255. Then each value we should multiply it by 255. 0 multiplied by 255 will give 0. 0.3 multiplied by 255 will give 76 point something. Always we round the number to we make seal for a number. If it is, for example, 76.1, we will put it 77. And 0.125 multiplied by 255 will give 32. Java 2D uses the paint interface to unify different paints. The class color, gradient paint, and texture paint all implement the paint interface and can be used to be graphics 2D objects. The set color, color C method belongs to the older graphic class. It sets only a solid color for rendering. The graphic 2D class of Java 2D contains a much more powerful set paint P method to control the rendering colors. Paint is a generalization of set paint P method to control the rendering colors. Paint is a generalization of color. So the paint interface is implemented by the color class and also implemented by other classes, as we can see here. This represents more attributes than simple solid colors. The gradient paint defines a type of paint with varying color. A gradient paint defined by 2 points and 2 colors, as we will see next. So the gradient paint class defines a type of paint with varying color. A gradient paint is specified by 2 points and 2 colors. As the location moves from the first point to the second point, the paint color changes gradually from the first color to the second. A gradient paint can be cyclic or acyclic. A cyclic gradient paint repeats the same pattern periodically. To create an acyclic gradient paint, the following constructor can be used. Gradient paint float x1, float y1, color c1, float x2, float y2, which is the second point, color c2, or by defining the point 2D P1 color C1 and point 2D P2 color C2. In either version, 2 points are specified with their associated colors. The colors for points between the 2 given points will change gradually from the one specified color, which is C1 in this case, to the second color. Also, cyclic gradient paint can be created by following constructor. By adding the true, by default it is false, the fifth argument. And if we put it true, then it means that cyclic gradient, which means repeat the same pattern periodically between the 2 points. For the setting the last parameter to true will construct a cyclic gradient paint. This example on paint: write a Java code to display a square. Upper corner is 1010 and the width and the length of the square is 200 using cyclic gradient paint with color varying vertically. Vertically means from along the y-axis, from down to up or from up to down, as we like, from red to green, vertically. Then here, as we can see, we create a new rectangle, upper corner 1010, and the width and the length is 200. We define the paint, which is the gradient paint equal new gradient paint. Vertically, we choose the highest point they ask you about cyclic. Cyclic means we repeat the same pattern periodically from 200 to 100, same x, and we move along y by 50 to see the repeated pattern. Since the size of the length of the rectangle is 250, then we will see the pattern is repeated 4 times, as we can see here. 1, 2, 3, 4. Okay, from 200 to 100 by red to 200, 150 by green, and then it will continue green to red, red to green, green to red, and then we put G2.set paint, and then we fill the rectangle with this paint, which is defined on the G2 graphics. The same example as before. Write a Java code to display a square, upper corner 1010 and the width and the length is 200, using cyclic gradient with a color varying horizontally. Then we should change x and leave y as it is, from red to green. Here also we define the rectangle, and we define a gradient paint from 1010 to 5010. Since it is cycle, we set it to 10 to true, and then we set the paint, and we see the cyclic gradient paint repeated along the square horizontally. Here also we should write a Java code to display a square using cyclic gradient, but now we will vary diagonally. Okay, diagonally, then we should varying x and y at the same time. So from 10 to 10 to 50, 50, we will see a cyclic gradient change diagonally from 10 to 10 to 50, 50, and repeat over all the path along the square. Okay, now we will talk about the texture paint class. The texture paint class allow an object to be filled with a texture pattern instead of color or anything else. Here we will color the image using a texture. An image and an anchor rectangle are used to define a texture paint. When painting with the texture, the image is repeatedly applied to the tiled rectangle region. A texture paint object is created with the following constructor: texture paint, buffer image, rectangle 2D anchor. The image defines the texture for painting, and the anchor rectangle specify the position of the image in the user space. In this example, this is the output of the code. As we see before, this program draws 3 visual objects in the paint component method. The top rectangle is drawn with the cyclic gradient paint that specify a gradual change of color from white to gray. The pattern is cyclically repeated. The ellipse is filled with a texture paint by the defined image from a URL page, and a text string is drawn with acyclic gradient paint. The gradient paint change from the color from white to black. The color pattern does not repeat. Align, we will discuss now strokes. A line rendered in computer graphic is not an ideal line with zero width. Practically, lines must have specified shape. The attributes that define the fine details of such shape are called stroke. So a stroke may include attributes such as the width of the line, the dash style of lines, the cap shape at the end of the line, and the style at the joins of lines. We will see the stroke interface in the next slide. Java 2D includes the interface strokes to represent strokes. A concrete implementation of the stroke interface in the basic class basic stroke. So, basic stroke provides a setting for width and style, join style, and dash. Here we have several constructors of basic strokes. Basic stroke with no argument or one argument, which is the width, three arguments, etc. First, we will talk about the parameters one by one. The parameter width defines the width of the drawing line, which is a float parameter. Then the parameter cap sets the end cap style and can take values. Cap underscore but which as we can see in the figure here gives a rectangular shape at the end of a straight line. The parameter join defines the join style with values join underscore bevel. As we can see here, the intersection of two straight lines will be as we can see here. The join underscore meter, which means we elongate the two lines to intersect at a point, and join underscore round to make a round shape at the intersection. The meter limit sets a limit for the join meter to prevent a very long join when the angle between the two lines is small. Then the perimeter join meter is only a limit for the join of the two straight lines in the join meter. The dash array in this here